idea. I know how to make crystals. How? I have a video on YouTube right now. Go look it up. First, starting off with the copper 2 sulfate crystal, you'll need a hot plate, at least 2 beakers, a glass stirring rod, 64 grams of copper 2 sulfate, hot hands for safety, a glass lid, and distilled water. Once all the materials are ready, turn on the hot plate to a low or medium setting. You grab 250 milliliter beaker and you pour it in. Once the 64 grams of copper 2 sulfate has been poured into the beaker, measure 100 milliliters of distilled water in your second beaker. After the distilled water and copper sulfate have been measured out, pour the water into the beaker with copper sulfate and place that solution on a hot plate. Because water is a polar solvent, it can easily dissolve ionic salts such as copper sulfate with little or no heat. The polarity of water leads to the positive ions of copper being attracted to the partially negative charged oxygen atoms, and the sulfate ions being attracted to the partially positive charged hydrogen atoms. Then you put the copper and water on the beaker and you start to dissolve it. If you need to, you can use a stir rod to help it. So once this is fully dissolved, you grab a couple pieces of copper sulfate from the stock and you add it to the solution, and then you use a watch glass and cover it. As the solution cools down, copper and sulfate ions will begin to attach back again, forming orderly crystals. After a day or two, a layer of seed crystals should have formed at the bottom of the solution. Using tweezers, remove that layer and place it on a clean, dry towel. If the crystals are attached like mine, you can use your choice of tools to gently tap and break the crystals apart. When it's out of solution, copper 2 sulfate is an ionic bond between a transition metal and a nonmetal. Sulfate takes 2 copper atoms and gains a negative valence charge, whereas copper gains a positive valence charge. The sulfate is bonded in a covalent bond of polarity, oxygen having the higher electronegativity, and therefore pulling the electrons closer to its nucleus than to sulfur's nucleus. Once you finish breaking the seed crystals to the size and shape of your liking, set them aside. Then go and weigh out another 5 grams of copper 2 sulfate from your stock and pour it into your solution. Then place your solution on a hot plate until the solids have dissolved. While your growing solution is cooling off, tie your seed crystal onto one end of a thread, then loop the other end of that thread through an index card. Then place that index card on top of your beaker with the seed crystal hanging at least an inch above the bottom. Once that is done, place a lid on top of your beaker, allowing your crystal between a couple of days to weeks to grow. Moving on to the iodine crystals, the materials needed include a Erlenmeyer flask, watch glass, a scoopula, some ice, and iodine. So, in this process, take a very little amount of iodine and place it into the flask. Then you put a watch glass followed by a piece of ice on top of the flask. Once that is done, place the entire thing on top of a hot plate. Keep in mind, iodine is a poisonous element, so this needed to be done in a confined area. When iodine is heated, it sublimes. Sublimation is the process in which a solid substance surpasses the liquid phase and turns directly into gas when heated. Although atoms within an iodine molecule pull closely together by a covalent bond, the molecules have very weak interactions with each other, which is also known as London dispersion forces. Due to the fragility of these intermolecular forces, iodine crystals break down easily when heated and break into a thick purple-colored vapor. After the iodine has turned into gas, turn off the hot plate and remove the flask, disposing of the melted ice on top of the watch glass. As you can see, when iodine in its gas state hits the cool surface of the watch glass, it turns into a solid crystallized form.